Okay, the objective for this video is to introduce you to parallelograms or definitions and the properties that flow or follow from the definition of parallelogram. So below you have a nice nifty parallelogram, and the definition that we're going to work with is that we have a quadrilateral, four sides. So we're talking about quadrilateral that's a four-sided closed figure with both pairs of opposite sides parallel. So the yellow sides are one pair of opposing parallel sides, and the purple sides are also another pair of opposing parallel sides. So you got purples are parallel, yellows are parallel, it's a parallelogram. Now, based on that definition, we're able to show that some properties follow from that. And here's the first couple properties which pertain to angles of a parallelogram. So by definition, we're going to set up this parallelogram with two pairs of opposing parallel sides. And what I'm going to do for this purpose is extend all these parallel lines. And we're going to work with the angles. And so I'm going to give these angles some numbers. So I'm going to call this angle 1 here. And recall that when we have parallel lines, we have lots of angles that will be congruent. One type of angle relationship that will be congruent will be corresponding. So those two angles, 1 and 2, are congruent, corresponding angles along these parallel lines and along this transversal. So 1 and 2 are both, we'll call them both green angles. Now if we shift gears a little bit, and if we think about these opposite sides being parallel by definition parallelogram, and we work along this transversal, then this angle 3 right here and this angle 2 are alternate interior angles and are also therefore congruent. So what I've established therefore by the transitive property is that angles 1 and 3 are the same. Okay, they're congruent. So that's a first property of a parallelogram. And note how I started with a parallelogram by definition, both pairs of opposite sides parallel, and I worked through an argument. It's not really a proof, more of an explanation. Although if I wrote it out, it would be a proof. So in any event, one property is that opposite angles, and angles 1 and 3 are opposite angles. They're opposite each other within the parallelogram, the original parallelogram. And those are going to be congruent. Okay. And there's another angle relationship I can establish. Here's an angle right here. I'm going to call this angle 4. And if you take a little peeky at angles 1 and angle 4, those are same side interior angles along these parallel lines. Parallel lines come from definition parallelogram and this transversal. And if you recall, the same side interior angles are supplements. And so these guys, 1 and 4, are going to be supplements. Okay, and that's a way to establish another property, more pointedly, that we call those consecutive angles in a row within the parallelogram are going to be supplements. Okay, so we either have opposite angles are equal, like angles 1 and 3, or consecutive angles are going to add up to be 180, like 1 and 4. Okay, that will hold true for all parallelograms. Another parallelogram property has to do with the opposite sides. So we know by definition opposite sides are parallel. So again, we're going to start with a definition, and I'm going to use this diagonal for this particular idea, and we've got some alternate interior angles we can establish here. These alternate interior angles are going to be equal. Again, the lines are parallel by definition of parallelogram, and also these alternate interior angles are going to be congruent. And by the reflexive property, this blue diagonal is congruent to itself. So what do we got? We got two triangles. The bottom one and the top one are going to be congruent by angle, side, angle, angle, side, angle. So since they're congruent by angle, side, angle, that makes their opposite sides congruent by CP/CTC. Okay, so what I've just established quickly is another property of a parallelogram. This is the third property, that the opposite sides are congruent. And again, the opposite sides are parallel by definition, but from that definition we can also show that the opposite sides are congruent by property. And again, the way in which we would explain or prove that is by establishing that these two triangles are congruent by angle, side, angle. And then therefore, by CP/CTC, those sides have to be congruent, and by CP, CTC, these corresponding lengths have to be congruent. Okay. The last property has to do with the diagonals themselves, and so we're going to take a little different approach and establish this through a specific example and then make a generalization from that. So I'm going to plot a parallelogram, and it is indeed a parallelogram. You have to just trust me on that. You could verify it by finding the slopes of both pairs of opposite sides and showing that they're equal, which would therefore make it by definition a parallelogram. Okay, and again, you can do that quickly by showing the slope of this guy. 4 minus 0 over 2 minus 0. 4 over 2 is 2. And this guy, 4 minus 0 over 12 minus 10 is also 2. And both of these have, therefore, this slope of 2, that slope of 2 is parallel. And these both have slopes of 0, so they're parallel. So it does satisfy the definition of parallelogram. What I do want to do, however, is establish that the diagonals, though they're not congruent, do bisect each other. And so one way to do that is show that they have the same midpoint. Okay, so one way to do that, again, as I said, is to show they have the same midpoint. So I'm going to find the midpoint of this first diagonal by using the midpoint formula. And so that says so between 12, 4 and 0, 0, the midpoint is going to be 12 plus 0 over 2, which is 6. 4 plus 0 over 2, which is 2. So that's going to be the midpoint between 12, 4 and 0, 0. Okay. I'm going to find the midpoint of the other diagonal. And again, I'm going to take the average of the x's. So the midpoint of the other is going to be 2 plus 10, which is 12, over 2, which is 6. 4 plus 0, which is 4, over 2, which is 2. And that's the midpoint of this other diagonal. So what I just showed is, lo and behold, they have the same midpoint, which means they bisect each other. They cut each other in half. And so that's the final property of a parallelogram. And we can use this idea in more general terms. This is a specific problem, but it does hold true for all parallelograms. The diagonals bisect each other. Bisect each other. Meaning that this piece here is equal to that piece, congruent segments, equal lengths, and this piece here is congruent to this piece here. Okay, so to summarize, we have the definition of a parallelogram, which looks like this. Both pairs, opposite sides, parallel. That's a definition, okay, in a visual sense. And from that definition, we're able to establish some properties. So on this side, we're going to have the properties that come from the definition. Number one, we have opposite angles are going to be congruent. Number two, consecutive angles are going to be sups. Number three, opposite sides are parallel by definition and congruent by property. Okay, and number four, the diagonals are going to bisect each other. They have the same midpoint, just as a specific example I showed you has. Thanks for listening. We will use these soon. Bye-bye.